Hello again with the second video with Basil Hassan. We studied in the previous video that physics is a study of energy, and I mentioned some branches of the physics: mechanics, acoustic and sound, optics and light, electricity and heat. And I promised you in the previous video that I want to talk in this video about the main branch of the physics, and I call it physics Netflix. Why Netflix? Because all of us know that Netflix collect all the movies, all the series, all the program shows in Netflix. Is that the same for the main branch of the physics, mechanics? Mechanics collect all the branches of the physics. And if we understand the mechanics, we can make a rigid understanding for the rest branches of the physics. Let's talking about the mechanics. The main parts of the mechanics: kinematic and energy and dynamic. The kinematic study the motion, study the velocity, the speed, the acceleration. All of this we studied in the kinematic. The dynamic study the forces and Newton laws, and the energy study the energy. Now, we want to start with the first part of the mechanics, kinematic. I told you that kinematic is speed, velocity, acceleration, kinematic equation, and projectile motion. We want to study this part in the kinematic. Let's just start with the first one. But before starting with the first one, I want to explain how we can use physics with the symbols and the equation. I consider physics like a language. It's like English, like Arabic. It's like any language. And if we want to study the language, we want to start with the alphabet of this language. The alphabet and the letters for the physics language, we can start with the quantity. What is a quantity? Quantity consists of three main parts. The first is a symbol, the second is magnitude and a number, and the third one is a unit. The first one, the symbol. For example, if I want to represent the time, instead of the time, we can write T, the symbol for the time. If I want to represent the mass, instead of writing a mass in the equation, we can write M, the symbol for the mass. If I want to represent the distance, instead of that, we can write D, the symbol for the distance. The second part of the quantity is the number and the magnitude. For example, the time is equal to 20. This is the magnitude of time. The mass is equal to 40. This is the magnitude of the mass. The distance is equal for 10. This is the magnitude of distance. And we have the last part of the quantity is a unit. We said that the time is 20. 20 what? 20 seconds, 20 hours, 20 days, 20 years. That's the unit is responsible for. For each quantity, we have the unit. And the mass, we have 40. 40 what? 40 kilogram, 40 ton. We should write the unit for the mass. And the third part is the distance. For example, we have a 10. 10 what? Kilometer, meter, centimeter. This is responsibility for the unit. Let's go back to the kinematic in the mechanics and talking about the speed. All of us know what is the speed. It's how fast an object is. How fast? This is the speed. But in physics, we should write it in another manner. In physics, speed related to two quantities. The first is distance and the second is the time. Let's talking about the first quantity, distance. For example, if we have a car going from Istanbul to Paris in 10 hours, and we have another car going from Istanbul to Roma in about 10 hours, the same time. We have more speed in the first situation because we have more distance. And we have lower speed in the second situation because we have less distance. So, the relation between the speed and the distance, we call it directly proportional. The more speed we have, the more distance. The more distance we have, the more speed. This is a relation between the speed and the distance. The second quantity, speed related to it, is time. Time. For example, if we have car going from Istanbul to Gaziantep for 10 hours, and we have another car going from Istanbul to Gaziantep in 5 hours. In the second situation, we have more speed because it's take a less time. So, when we have a less time, we have more speed. And the relation between the speed and the time is inversely proportional. The more time we have, the less speed. This is the relation between the speed and the time. In summary, we can say speed related to two quantities. The first is distance, and the relation between the speed and the distance is directly proportional. The more distance we have, the more speed we have. And the second quantity related to the speed is the time. The more time we have, the less speed we have. So, the relation between the speed and the time is inversely proportional. In physics, we found it's hard to write all these sentences to describe the speed. So we use the math in the physics. How we can use the math in the physics? First, we can use the alphabet of the physics, the quantity and the symbol. We can use S as a symbol for the speed, and a D is a symbol for the distance, and a T is the symbol for the time. And the relation between the speed and distance and the time is like this. We see from this equation the position for the speed and the distance are in the same in the two sides of this equation. And this meaning, in math, the relation between the speed and the distance is directly proportional. And we see from this equation the position for the speed and the time are different in these two sides of this equation. That's meaning in math, the relation between the speed and the time is inversely proportional. And this is the language of the physics. This equation represents to all the sentences we talking about like this equation. I know all of you know what is the speed, and they can calculate the speed if they have the distance and the time, like numbers. But the real physics to understand how this formula, how this equation comes from. This is the physics. All the equation in the physics, all the formula in the physics refers to the same sentences. My mission in this channel to explain all the equation of the physics. In other words, we want to translate the physics language. See you in the next video in the mechanics and in another concept of the physics. Goodbye.